prepared to talk to our judges now? So our last speaker of the night is Tom Conroy, who's going to talk about how to put your project together so that you have that wonderful experience with the judges.
Okay, hi. So what I was going to talk about was primarily the preparation of the board, which, as you'll find out in a minute here, is pretty much the biggest part of the judging experience. Before I started, I just want to say that the science fair targets students from 6th grade all the way up to high school seniors. And so there's a lot of variation in the amount of information and experience they bring to the fair. And so what we're trying to do is encourage these students to get better and better as they go through their different research topics and prepare them for real life experiences. Because I tell you from my kids' experiences, this fair and then ISEF dramatically prepared them for college. So I really want to encourage everyone to get your students excited about it and get them involved, so that it really does prepare them for life's adventures. So anyway, for the younger students, you might want to start with a review of the scientific method. You want to get them interested in something that they are really interested in, because that's what's going to motivate them most to carry on the work, as Chuck described. And you really want to do more than just an afternoon's work. You want to do several weeks probably, or maybe even a couple of months if they can afford the time, to take an idea, a question that they have, investigate it, do some real research, and then prepare possibly an experiment and draw some conclusions from it. And so that's basically the scientific method. First, you identify why you're doing this. What is the purpose? What is a question that you are interested in? You go back and then you start looking what other people might have done to develop more information that can really direct your research. And then you make a guess as to what caused that particular thing to happen that you're interested in. And so then this is where you might want to, you have to prove out that hypothesis. And so typically we design an experiment to do that. And so, you go off and figure out what your experiment's going to be, figure out how you're going to do it, and then go and execute. Finally, you're getting a bunch of data. You got to figure out what conclusions to draw from it, how to analyze it, use different approaches, different tools. It's very important you understand, at least to some level, what those tools are telling you. You can't just plug numbers into an Excel spreadsheet and say, yeah, I did this. That doesn't really score a lot, and it doesn't teach you a lot. But so you got to get a little bit deep into what the meaning and the methods that you're using. And then finally, draw a conclusion. And that's very important. Even if your hypothesis fails, it's still a very valid experiment. And that's something that the students should be encouraged. If they've gone through several months of work and their hypothesis was wrong, that's an acceptable project. As they say, Thomas Edison, 90% of his telephone calls failed before he finally got through. Or not, I'm sorry, Thomas Bell, before he finally was able to make the first phone call. So that's an acceptable way to learn. And so speaking of references, at the bottom I did my job and I put a reference to where I got the scientific steps. But as has been emphasized, we do want the students to go out and look through other people's research and get ideas, but then always provide proper credits. Okay, next slide. So the judging process has been a little bit codified. There's still a lot of interpretation and we rely on the judgment of the judges, but we have what we call rubrics in the student handbook that can be viewed by all the students just to get an idea of what the judges would be looking at and how they might weigh the different aspects. But if you look at the different criteria, there's scientific thought, experimental methods, what approach the student used to analyze the data, their visual presentation, which is the board, and then their oral presentation, which is how they interact with the judge. Okay? And so some of the do's and don'ts for the board. I'm going to show a couple examples following this, but just first verbally lay it out. There's basically three extremes. I only list two here, but they're well laid out. They're either overcrowded, or the other extreme, which I didn't really talk about, was there's nothing really there. There's insufficient information. So let's just talk about the first. Let's compare and contrast well laid out versus overcrowded. You have a logical layout, a nice flow that the judge can make his way through the board. Keep in mind that the first part of the judging process, the students are not present. The judges go to the board. They have a couple minutes to look at it, draw some idea of what the project's about, get some questions in their head, and then they do that for their assigned projects. And then when the students come in, they use that time to interrogate the students and try to see, either validate what's on the board or draw more information about the depth of their understanding of the project. So it's important that the project board can stand at least mostly on its own, so that the judges can actually draw those questions from it. It has to be readable. Okay. One of the biggest mistakes, I think, is the student wants to put their entire project on the board. We see projects that are, I don't know, they're probably about 5 or 6 feet tall. They're up on a table, so the judge they can't even see the top of the board. They'll put multiple layers on it with different pages from the research document, thinking that the judge is going to have time to sit there and read it all. They don't. They only have a couple minutes. They want to do a good job, but if there's too much information there, then they're just not going to be able to process it. It also has to be, you have to get a balance between flashiness and just good technical presentation. So you like to use some colors. You might want to use a nice different font, something more creative. Just make it without getting overboard. Okay. Second thing is pictures are very important. You want to get a good balance of text and graphics. The old saying, a picture's worth 1,000 words is very valid here. A photograph of the student doing a research or their procedure may avoid 25 steps listed on the board. So incorporate graphics, incorporate figures of data, and so forth. And the last thing is you really want to highlight the hypothesis and the conclusion, and the whole idea is to be able to draw, for the judge to be able to see that the conclusion can be supported. And so there has to be some basis for what the conclusion really was. So I'll give you two examples. Unfortunately, I didn't have any photographs of the projects, but this just a way of visualizing it. So up top, back up a step. The project board is a trifold poster board. They're available at any office supply store if you haven't gone through this before. The top is a header board where you put your project title. Notice I put a couple little graphics up there just to make it stand out a little bit. And then I have a flow here it doesn't have to follow this flow, but it just seemed like a nice thing to talk through. Right up front, in the middle, bold letters is what the problem is. What's your hypothesis? And then I always read right to left, so I start over left to right, sorry. I started on the one side, and I start with my project overview, a couple of bullet points, or some way of describing the research, what I'm looking for in terms of variables. And then I went back to the middle, showing what the experiment was, what the procedure was, what kind of materials, what kind of flow chart I used, include some data, some observations, create some figures, and then finally draw some conclusions. And then down at the bottom somewhere, you really do need to have the references. They can be very small print, but they've got to be somewhere where you're using someone else's work. You got to give people credit where credit is due. And then the next slide is a garbled mess. This is where you're getting way too much information, and so as you can see, it's not even appealing. And so the judge looks at that. He's trying to draw conclusions from it, trying to draw questions, and he just gets lost in it. So that's what you want to avoid by putting too much information on the board. All right, and then finally, just some additional things. I guess just to emphasize, too much information actually hurts. There's just not enough time to go through for the judge to go through a lot. Picture is worth 1,000 words. Very important that they can defend what's on the board. If they go into a lab, for example, and they use a piece of hardware that helps them, investigate their topic, they at least have to have an overview of what that piece of hardware does. They don't have to go into excruciating detail, but they at least got, it's more than just I went in there and I pushed a button and I got a picture. There has to be some depth of what that machine did. Math is we're always looking for math. Even a simple average is useful. The older students should do better than that, but science is all about math also, so include it. Use the board to tell a story. What I like to always see is the students during the oral presentation, they'll stand in front of the board and they'll start pointing to important parts to emphasize their discussion. That really shows the judge that you know what you did, and you really want to emphasize that. So it helps connect the student with the judge a little bit better. References, again, emphasize that. And then finally, make sure they have fun. I mean, this is a learning opportunity that will take them through their life, and they need to enjoy it and not look at it as a punishment almost. It's something that they can have a lot of fun with, and they can actually win some pretty neat prizes if they follow through. That's all I was going to say.